record.
Okay, cool. So for my first implementation, I implemented a pendulum functionality in which if you go to the scene view and move this ball around, it swings back and forth based on how much force you push on it. And then for my second example, this is more like a wire or cloth implementation in which if you pick one of these spears and you just pull them in one direction or the other, the all the other spears sort of react to that pull. And then for my third example, I have this cloth animation, which is simulated by some sort of wind with the cloth component, and it has a spear collider in which if I move it to here and it collides with the spear, it kind of bounces off, just like that. I forgot to mention with the last example that I used a rigid body configurable joint for the first spear and all these other spear, but with these other spears, I also use a spring joint so that it can react to the other spears if one gets pulled. And now I'll lead it back to Shini to show off his.
Hi, this is Xingyi. Thank you, Elisa. For our project 6, I'll first do the illustration for math. As I mentioned in the previous video, I'm using Hooke's law. It's a physically based implementation for my lab 6. I will have a component, a field which is L rest. This is supposed to be the L rest, and this one is the L current. If we use the L current minus the L rest, we get an X. What is this X? This X is the displacement, which we use later to calculate the force we're pulling the spring downward. In order to calculate the force, we will use Newton's third law, which is F equals ma. Assuming that mass is always equal to 1 for both the spring and the anchor, we will have X only equals to a, the acceleration. And we know that speed, which is v, equals to v plus acceleration each frame. Therefore, it's because acceleration equals f, the speed is equal to f. Therefore, we will have a simple equation to implement. For the tasks, we have separated the tasks into several code segments, and I want to mention that code segment 9 and 10th have been aborted. This is a snapshot of my project illustration. The left is the spring that contains vector implementation. The right is just a simple numerical implementation. Now I'm going to direct you to my actual project in Unity. Here, both works fine, and for my last implementation.
You're not sharing your Unity screen, by the way, still on the presentation.
Oh, is it sharing the Unity screen?
No.
Sorry about that. Let me replay that. For my previous implementation, the left side, which is the vector implementation, doesn't work. I found out that it's because I'm using the fixed update, and I'm using update instead of fixed update. And in my update function, I'm not using time.delta time. That's why it's running as fast as my computer can afford, which is much more faster than this side. But for this time, both of them I think have a constant speed. And eventually they will all stop at y equals 0, which is where they initially are. I have a couple fields here for you to control. The first one is the anchor, the second one is the sphere. And K is the coefficient included in Hooke's law, and L rest is set to 2. In vector implementation, we will have vector a vector of initial force, which is 0, -2, 0. That means we are pulling 2 units down, downward. And for the gravity, I'm using damping to replace it, which is set to 0.99, else the spring will bounce up and down forever. That's pretty much my implementation. For code-wise illustration, please see my Unity package. And thank you very much.